Okay, here's a quick video on testing your soil. This is an example of a soil sample, and we've labeled this one E. This is soil sample E. And here's kind of the end result of what we're looking for um, in a analysis. We're trying to separate the soil sample that's all mixed together into constituent textures of sand, silt, and clay, and understand the relative proportions of those so that we can then map those onto a soil texture chart. In this example, sample E is 12% sand, 18% silt, 70% clay, and then we can map that based on 70% clay, 18% silt, and 12% sand. We can map that onto the soil texture chart. Okay. Ultimately, we're trying to find a final mix that winds up in this sandy clay loam region here. So this is the first step, is figuring out what do you have on site and how do you need to supplement it with other types of soil, in this case a sandier source, to pull this on-site soil toward your more ideal soil mix for compressed earth block. So we're going to go through analyzing this other sample B, and I'll show you what that process looks like. So we start out with the native soil. This is the native soil sample B that we're working with. And first we need to screen out anything larger than 3/8 of an inch. So we're using a sieve to do that. And we only need about 20-25 milliliters of material to do our test tube texture analysis. So I'm just going to sort out this material. We'll see that we've got some large aggregate here. I'm going to put that into a bowl over here so we're not dealing with it. And now what we have left is anything smaller than 3/8 of an inch. So we're going to take our sand vial and we're going to fill it up to about the 20 or 25 milliliter mark. I typically like to go 20 milliliters, but and again, it doesn't have to be exact because we're going to total each constituent component to kind of get our divisor. That's 15 milliliters. And that's right about 20. We don't have to pack it, but I just want to have kind of a level line on around. So you can see that that's at about 20 milliliters in the vial. So next we're going to take some water, and then we're going to have a timer. I like to fill this up to about 40 milliliters. You want to leave yourself some room to shake. If you've got air in there, it helps it shake. But what we're going to do is we're going to mix this up for a minute. So you kind of need to watch your watch. So we're at the 40-second mark. We're going to mix this up really good for a minute. The idea here is that you're separating sand, silt, clay from sticking to each other, because you want to be able to measure them separately. Sometimes people will add a very dilute, a couple of drops of very dilute soap into this to help as a surfactant to kind of break things up, but I'm just going with the brute force, shaking it for a minute method. So we got about 20 more seconds to go. You're going to want to keep your stopwatch or a timer on your phone handy, because basically we're going to separate these by time. Sand settles out, it's the heaviest, densest particles. It's going to drop out of the water column the fastest. We're going to give it 30 seconds. So, all right. So I'm going to keep shaking until I have the top of the minute. All right. Now I'm going to stop and I'm going to watch for 30 seconds. And I'm going to get my silt tube ready, because what we're going to do as this settles out in 30 seconds, and you can already start to see the sand settling out. 10 more seconds. Basically, all of the silt and the clay is still suspended in this water. And so now what we're going to do is we're going to slowly pour out the suspended silt and clay into the silt tube. And you'll notice that I'm not shaking it to, I don't want to like shake any sand down into that, but that's basically, you can tap it to settle out and get the sand to go to the bottom. And then we'll just get that last liquid. So now we're left with about 12.5 milliliters. So then the next thing you would do is you would put your timer for 30 minutes, and we're going to let the silt settle out. In about 30 minutes, the silt is settled out. So then we're going to let that settle out, and we'll come back and show the final results. Okay, so for the sake of this video, to get it out to a friend quickly, basically, after 30 minutes, the silt will have settled down to the bottom of this vial, and then the clay would remain suspended in the water. And after 30 minutes, basically, we would pour the suspended clay water into the clay vial, and then we would let that clay settle out, and that would take about 30 hours. So sand settling, 30 seconds, silt settling, 30 minutes, clay settling, 30 hours. That's the rough way to do this without going into a expensive lab process and paying a lot of money. This is a way you can basically field test this wherever you're at if you've got some tubes like this. And what that will tell you, you'll get something that looks like this, where you can basically measure the relative volume of sand, silt, and clay, and then you can do your calculations to figure out what your percentage of each soil texture component you've got, and then you could use those to map onto your texture chart. And for something that's sandier, we're probably going to find something down in this kind of a range. If you're getting a sand source, you're going to have high sand. And that tells you that to get kind of into this purplish area, you'll need to mix a proportion of the sandy material with this more clay material in order to pull this range back down, pull the soil mix down into the ideal range. And that's basically a proportion that you can determine just by what's the relative proportion of the distance between your two soil samples, and then the point that divides that line, you know, depending on where you want to wind up, that defines your point. So let's say the soil, the sandy is over here. You've got a really sandy soil source that you can supplement with your local site sources. So this line, depending on what your relative proportion in your mix between these two, so this is type B. If you want to be, if you were to do half and half, then you're going to wind up in the middle right here, right? If you wanted to say, hey, I want more influence from this sand, then I'm going to mix more. And it's a little bit counterintuitive, but you were to say, hey, maybe this is going to be, I want to be more like a third of the way up this line, and I want to be 2/3 of the way from this line, then what you'd want to do is you'd want to put 2/3 of your mix with B and 1/3 of your mix with E to get to the kind of, you know, um, opposing so let's say this is, you want to be 2/3 away from E, then you want to put 2/3 of B in there. If you want to be 1/3 away from E, then you want to put 1/3. Sorry, if you want to be 1/3 away from B, then you want to put 1/3 of E in there. So it's a little bit counterintuitive, but that's kind of the how you would figure out the ratio. And then that would get you a mix, a predictable mix that winds up being at a particular point on the soil texture chart. And the whole point is to get something more ideal while you're balancing the usage of your local free site material versus maybe something you're importing, from a local quarry onto your site to help mix. So just depending on where you want to be, you determine your soil mix ratios accordingly. And that's the point of doing this soil texture analysis.